In today's lecture, we are in MD 5504 mathematical programming. We have seen that our transportation problems standard form is minimize summation xij times aij, where the xij is uh, transporting amount units and aij is the transportation cost from ith source to the jth destination. Subject to constraints, summation xij, summation is running from I is equals to 1 to m is aj, and summation xij, j is running from 1 to m is bi. That is, and of course your xij's are greater than or equal to 0. And we have seen that it is having a feasible solution if and only if the total demand is same as total supply. In that theorem itself, we have seen that how to see this actual solution, means a feasible solution to the given linear programming problem. But today, we will see a few methods to exactly find out at least initial basic feasible solution. So, which type of basic feasible solution will appear in this transportation problem, we will see in the next coming lecture, that is a theorem actually. But right now we will see that how to solve that, means how to get the initial basic feasible solution via few methods. The simplest method is the northwest corner method. So let first of all our transportation problem be like with, say, as we have previously taken, we keep with A, B, and C sources and the places where we are transporting, that is 1, 2, 3, and 4. The transportation cost, it is given, I am writing without worrying about anything, just giving any numbers. Okay? So the transportation cost I am writing with the blue color at the bottom corner. That is, here I am writing 10, 15, 12, 7, 16, 11, 13, 4, 19, 6, 17, 5. And the demand and supplies, I am writing here this supplies. From A, the maximum production that is we are going to supply is say 100 unit, here say 50 unit, and here say 150. And the demands at A, say it is 70, here it is say 130, here say 80, and here it is 20. So you can write, means you can solve this, means give any feasible solution via any approximation method, any way you have seen. I have given you as exercise to check that how many solutions you can find out. Now I am giving you the one method, so called north-west corner method. Why it is so called north-west corner method? So if we take this as a, in mostly the maps, it is written that this is a north side, this is the south side, uh, this is east, this is west. Mostly in all maps you will see like this. So northwest corner means topmost corner of the table. So this is our topmost corner of this table. This is just written, but the table is our this much only cost table. That is 10, 15, 12. This is our cost table. So this is our topmost corner of this cost table. Start from there. What you will do is from this demands and supplies. Here these are demands. So from these demands and supplies, whatever is minimum. So here it is 100 and here it is 70. So minimum is 70. So we will transport from A to 1 the 70 unit. Okay. Now here we have already transported 70 units. So here we are left with 0 amount, and here we are left with 30 produce material there. So here we will cancel this row just by inserting these values. Either you can write 0 or you directly cancel that row. So I am cancelling that row. Okay. So for the cancellation, right now I am keeping this highlighter. So I have highlighted means I have cancelled this row because there is 0 amount left. Now this whole column is removed, so we are left with this table, this cost table. In this cost table, the top corner is this, or northwest corner is again you can say this. Now search for the minimum possible. So in the northwest corner of our table, here we are left with only 30 unit, and here we are having possible 30 unit. So minimum is 30. So we will transport from A to 2 is 30 unit. So now here we are left with 0, and here we are left with 100. So we are this 2's demand 30 unit demand is satisfied, and we are left with 100 unit demand we have to fulfill. So again, since this is 0, we will cancel this row because now it is 0. Okay. So we will continue with this left corner table. So in this table we are having this as a topmost corner, means northwest corner. So there minimum of demand and supply, that is 15 and 100 is 50. So we will transport from B2 to 50 units. And now we are here left with 0 unit, and here we are left with 50 units. So since this is 0, we will again cancel this row because of this 0. Now we are having this table left. So in this cost table, this is our northwest corner. So here minimum from 50 and 150 is 50. So we will transport that much here. So this column is removed. Now here we are left with 0, and here we are required 100. Sorry, here we are having 100, and here we are the demand is satisfied, means 0. So this column is removed. Now this table is left. There we are having 80 and 100, so minimum is 80. So we will transport this north corner north corner table. We will transport 80 units, means from C to 3 we will transport 80 units. So here we are left with 0, here we are left with 20, and we will write here 20, means from C to 4 we will transport 20 units. See here also we have do that this column is cancelled. Okay, so if you observe here, the things are sum is 70 plus 30 is 100, 0 plus 50, so here it is 50, 50 plus 80 plus 20 it is 150, here 70 plus 0, 0 so 70, 30, 150, 50 is 130, 0, 0, 80, so it is 80, 0, 0, 20, so it is 20. Why it is happening? Because the total demand is same as total supply. See, total demand, total supply is 300 unit, and total demand is also sum up to 300. So when the total demand is same as supply, we can apply northwest corner method to reach the at least one feasible solution. One more observation, that the number of non-zero cells is this, that is 1, this is second, third, fourth, fifth, and sixth. So here number of non-zero cells are 6, means number of non-zero variables xij is 6. The total sources we are having 3, and total destinations we are having 4. So 3 plus 4 minus 1 is 6. And we will see in upcoming lecture that in any basic feasible solution we are having, whenever we are having m sources and n destination, then in basic feasible solution we are having m plus n minus 1 variables non-zero, means variables in basis is m plus n minus 1. The number of variables in basis is at most m plus n minus 1. That is our next coming lectures here. Okay. Before going to that, one more observation, that while calculating this, we haven't thought about the cost. So the northwest corridor method is not anyhow related to the cost, means transportation cost, means it may give you smallest transportation cost or maximum or anyhow between those two. Okay, so we don't know that where this solution will be. It will be near to the optimal solution or far to the optimal solution. Okay, but we one more in one more problem we see that how the solution, uh, how to solve problem by northwest corner method. So I am taking one more example. Now I will take more sources and more destinations. So say I am having sources A1, A2, A3, A4, and A5. Destinations are B1, B2, B3, B4, and B5. I am writing the cost table, but you know that actually in northwest corner method there is no need of cost. Okay. But still, because it is a transportation problem, we have to write the transportation cost. So I am writing it. So I am writing the cost table. So the cost table is 5, 8, 7, 6, 3, 6, 4, 8, 7, 6. It may be in lakhs or any. We are writing it as a unit. Okay. So 4, 6, 3, 2, 2, 5, 8, 6, 6, 3, 4, 5, 6, 4, 3. This is our transportation cost table. And the demands and supplies, I am writing the demand. Oh, sorry. Here we used to write company's name, so better to write here supply. So the supplies values are say here 20, 30, 50, uh, 70, and 30. So the total supply is 50 plus 50, 100 plus 100, so 200. And here, say total demand is 15, 35, 75, 25, and 50. So see here sum is 30, 50 plus 100. So 50 plus 100, 150 plus 50, so it is 200. So both are same. So we can have solution via northwest corner method. Okay. So to start with the northwest corner method, first of all, we start with the topmost corner. So this is our topmost corner right now. There, minimum of 15 and 20. It is 15. Minimum is 15. So here we will transport 15 unit. So this is now 0, and here we are left with 5 unit. So this column is removed. Now here we are having this is a northwest corner, and minimum of 5 and 35 is 5. So here we will transport 5 unit. So here we are left with 0 unit, and here we are left with 30 unit. So this is 0, so corresponding row will be removed. Now here we are having this as a northwest corner, so here we are having 30, here also 30, so here it will be transport 30 units. So we are left with here 0, and here also 0. So both row and column will be cancelled. Now the northwest corner is this. Now here minimum of 50 and 75 is 50. So we will transport 50 units here. So we are left with here 0 and 25 unit here. So this is 0. So corresponding row will be cancelled. Now the topmost corner in the table is this. So minimum of 25 and 70 is 25. So we will transport 25 units from here, and so we are left with here 0, and here we are left with 45. So we will remove this column. Now the topmost corner is this. Here minimum of 25 and 45 is 25, so we will transport 25 units here. So we are having this entry now 0, and here we are having 25. So this is cancelled. Now here we are having we are left with 25 units, so we will transport 25 units here. So we are left with 25, and here 25. So this is 0, and here we have to write 25 because to make this 50. So here we are having 30. So some mistake. 1, 2, 3, 4. Sorry, here we are left with after applying this 25 and 25. So first of all we have applied 25, so 45, and then applied 25. So here we are left with 20. So here we are left with 70. So we have transported 20 units, and here we are left with 30. So we have transported 30 units there. So here if you will calculate the non-zero entries, then here it is, this is 1, 2nd, 3rd, 4th, 5th, 6th, 7, and 8. So here we are having non-zero entry 8. The number of basic solutions, number of sources is 5 and number of destination is also 5. So 5 plus 5 minus 1. So this is 9. So we are having less than 8, 9. Sorry. We are having less than or equals to 9, the non-zero entry. So the things I am going to say is in basic we will have at most at most n plus n minus 1 variables in basis, and here this sum you can check that 15 plus 5 is 20, 30, here it is 50, here it is 20 plus 20, 25 plus 25 plus 20 is 70 and 30. So row sum are also satisfied, column sum is also satisfied, you can check that it is 15 plus 5 plus 30 is 35, 50 plus 25 it is 75, 25 and 20 plus 30 it is 50. So via northwest corner method, we can go to the basic feasible solution that actually is from the next coming lecture. Okay, still here also you observe that we haven't worried about any transportation cost. Okay, so in the next method, we will see that how actually transportation cost can help to reach to the near to the optimal solution. Means we can develop a method to directly lead towards the optimal solution. Okay. So try any random question, write down any random question I have written in this way. You can write any random question and solve it via northwest corner method. I am giving you few problems here also. So say our problem is having, I am not writing transportation cost, you can write randomly, okay. So I am writing just A, B, C, D, 1, 2, 3, 4. The demands and supplies are 150, 210, 240, 50. So the total demand is 4 plus 1, 5 plus 5, 0, 0, 2, 2 plus 2, 7, 700. And the total demand, this is total supply, and total demand is say 100 plus 200 plus 300, 26 and 100. So this is your problem, and you try to solve this as a transportation problem. Solve it means get a initial basic feasible solution via northwest corner method. You pause the video here and try by yourself. See, here I am giving the solution. So here minimum is up from 100 and 150 it is 100. So this will be 0. So corresponding column will be removed. Here we are left with 50 units. Now from minimum of 50 and 200 it is 50. So here we are left with 0. So this row is cancelled. Here we are left with 150. Now minimum of 150 and 210 is 150. So we are writing 150 here. So we are left with 0 here and 60 here. So this column is removed. Now here minimum is 360. So it is 60. So this is cancelled. Here we will 0. We will have 0 and here we will have 240. So here we are having 240. This is these two things are cancelled, and here we are having 50. Here sum is 650. Sorry. So here must be is 50. So here it is again 50. To get the solution via northwest corner method, we know that both sums should be same. So both sum are 650. And this is our initial basic feasible solution via northwest corner method. Okay? So try such more problems, write problems your own, and solve it via northwest corner method. Stay at home and stay safe. Thank you.